Alright, so today we're going to be talking about adding and subtracting linear expressions. And you'll see that they are similar, although the process is a little different. Make sure you have these notes downloaded into GoodNotes so that you can copy them as we're going. And also make sure you have a bag of Algeblocks, as we'll also be using those throughout the lesson. Alright, let's go ahead and get started. We're going to first talk about adding linear expressions, and then we'll move into subtracting linear expressions. Now, the first thing you might be wondering as we go through this lesson is, what is a linear expression? Well, a linear expression is an algebraic expression in which the variable is raised only to the first power. So let's write that down. So what is a linear expression? An algebraic expression in which the variable is raised to the first power. All right. So let's just review some examples of linear expressions and nonlinear expressions. A linear expression could be 5x, whereas a nonlinear expression would be 5x squared. Notice that it's now raised to a power other than 1. Another linear expression might be 3x plus 2, whereas a nonlinear expression would be 3x squared plus 2. Another linear expression might be x minus 7, whereas a nonlinear expression would be x to the 4th power minus 7. So you can see the difference there. In our linear expressions, all of our variables are raised only to the first power, whereas nonlinear expressions can be raised to other powers. We will only be working with linear expressions during these lessons. One very important, essential question that we'll be looking at is, how is adding linear expressions similar to simplifying expressions? So you recently learned about simplifying expressions. As we're going through this lesson, try to think about, what are the connections between the two ideas? How are they similar? How are they related? How are you using your knowledge of simplifying expressions to help you add linear expressions? All right, let's move on. Now, for each linear expression that we add, we're going to be doing this two different ways. We're going to be doing it with the Algeblocks, and we'll also be doing it numerically, because, unfortunately, we can't walk around with a bag of Algeblocks our whole life, but it does help us to visualize the expression and what we're doing. So the expression we've been giving is 2x plus 3 in parentheses plus x plus 4 in parentheses. Okay? We're going to try this first with Algeblocks. When you model with Algeblocks, okay, there are 3 total steps. First, we have to model each expression. Then step 2 is to combine like blocks. And then the third and final step is to write your simplified expression. Okay, so to do this, make sure you have your bag of Algeblocks and Algeblocks Basic Mat, and make sure you have your camera open to take pictures of your work. So, we're going to start by modeling 2x plus 3, okay, and also x plus 4. I'm going to pull up my camera, and so you can see we've got our Algeblocks, a little bit. We've got our Algeblocks Basic Mat here. Okay, I'm first going to model 2x plus 3. So remember, our yellow blocks here represent x. So I'm going to put 2 of those in the positive section, along with 3 green cubes to model my plus 3. Okay, I'm also going to model x plus 4. So I'm going to put another yellow x block here. Okay, plus 4 green blocks. Okay, so at the top here I've got 2x plus 3 showing, and the bottom here I've got x plus 4. So I'm going to go ahead and take a picture of that, and then we're going to drop that into GoodNotes. All right, we can see that step 2 is to combine like blocks. So let's go back to our algeblocks. And what we're going to do is go ahead and combine like blocks. Since they're all in the positive section, we can just go ahead and combine all our x's together. Okay, and go ahead and combine all of our green cubes together. All right, and again, we're going to take a picture. And drop that into GoodNotes. Okay. And then the last step, remember, is to write that simplified expression. So I can see here that I have modeled 3x plus 7. Okay, and that's my simplified expression. Now we're going to try this same expression numerically. Okay, when you're adding linear expressions, the first step is to just go ahead and remove those parentheses. So I'm going to rewrite my expression without my parentheses. So 2x plus 3 plus x plus 4. The next thing we're going to do is color code our like terms. Yes, color coding is back. Get excited. I know I'm excited. Okay? All right. So we're going to go ahead and color code 2x and x. All right. Pick a new color. We're going to color code 3 and 4. And then go ahead and combine those like terms. So 2x plus another x gives us 3x. And then 3 plus 4 gets us 7. So again, our simplified expression is 3x plus 7. So you can see here we get the same final answer no matter what method we use, so we know we did it right. So there's our simplified expression, 3x plus 7. All right, let's try another one. Here we've got 2x minus 1 plus parentheses x minus 5. So again, let's try this first with our algeblocks. Pull up my camera. Okay, so model each expression. So let's start by modeling 2x minus 1. So our 2x, remember that yellow block is going to go on the positive side. And then minus 1, so that green 1 is going to go on our negative side. Okay, then x minus 5, so we've again got a positive 1x. We're going to put that over here. And then minus 5. 1, 2, 3, 4, 5 green cubes on our negative side. All right, go ahead and take a picture. And let's drop that into GoodNotes. Okay, remember step 2 is to combine our like blocks, so let's go back to our algeblocks. Okay, all our x's are on the positive side, so we're just going to combine our x's together. Same thing with our green cubes, they're all on the negative side, so we're just going to combine those together and go ahead and take a picture. And drop that into GoodNotes. Okay. Last step is to write that simplified expression that we have showing there. So we can see that we've got a total of positive 3x showing. And then we've got 1, 2, 3, 4, 5, 6 green cubes in the negative section. So our simplified expression is 3x minus 6. All right, let's go ahead and try that numerically. So again, we're going to start by removing those parentheses. So we're going to write 2x minus 1 plus x minus 5. Now we're going to color code our like terms. So I'm going to color code our x's as one color. So here's that simplifying expressions knowledge helping you out. And I'm going to color code, and don't forget that minus goes with the 1, minus goes with the 5. Color code our whole numbers. All right, combine like terms. 2x plus a positive x gives us 3x. Minus 1 minus 5 gets us a total of minus 6. So numerically we can find that our simplified expression is 3x minus 6. So again, you can see that both ways we get the same final answer of 3x minus 6. Okay, let's go ahead and try another one. Now we've got 3x minus 5 plus 2x minus 3. Let's start with our algebra blocks and begin by modeling our expression. Okay, so we're going to start with our first expression, which is 3x minus 5. So I'm going to put my positive 3x on the positive side, and we're taking 5 away, so 5 green cubes over on the negative side. Okay, that's our first expression, 3x minus 5. Now we're going to show 2x minus 3. So again, our 2x is still positive, so I've got my 2x over here on the positive side, and then minus 3, so I'm going to put 3 green cubes over here on my negative. So again, my top expression is shown here, 3x minus 5. And then down here we've got 2x minus 3. Go ahead and take a picture. And drop that into GoodNotes. Okay. Next step is to combine our like blocks. So let's go back to our algebra blocks. Again, we've got all our x's on one side, so we're just going to combine all of our x's together on the positive side. And then same thing, we're just going to combine all our green cubes on the negative side here. Again, take a picture and drop that into GoodNotes. Okay, last step with the algebra blocks is to write our simplified expression we've got here. So we've got a total of 1, 2, 3, 4, 5x, positive 5x. And then we've got 1, 2, 3, 4, 5, 6, 7, 8 on the negative side. So 5x minus 8 is our simplified expression. Okay, let's go ahead and try that numerically now. So again, step 1, remove those parentheses. So we've got 3x minus 5 plus 2x minus 3. Okay, now we're going to color code our like terms. Again, that's simplifying expressions right here. So I'm going to color code 3x and 2x together. And my minus 5 and my minus 3 are going to go together. And then let's go ahead and combine like terms. 3x plus 2x gets me 5x. Minus 5 minus 3 gets me minus 8. So my simplified expression is 5x minus 8. So again, you can see that we get the same final answer both times, so we know we've done it correctly. Okay, let's try another one. This one we've got 2x minus 4 plus 3x minus 7. So again, let's start by modeling each expression with our algebra blocks. So we're going to start by modeling 2x minus 4. So again, I'm going to model my 2x on the positive side here. And I'm going to take 4 away. So 4 on the negative side of my green cube. So again, I've got 2x minus 4 showing. Now I'm going to show 3x minus 7. So I'm going to take 3 x's and put them over on my positive side here. And I'm going to take 7 green cubes and put them over on my negative side here. So again, I've got 3x minus 7 showing on the bottom here. Go ahead and take a picture. And drop that into GoodNotes. Okay, next step is to combine like blocks. So let's go back. Okay, I'm going to combine all my x's together. All right, and combine all my green cubes together. Go ahead and take a picture. And drop that into GoodNotes. Okay, last step, write down the simplified expression that we have showing here. So we've got a total of 1, 2, 3, 4, 5x on the positive side minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5x minus 11 is our simplified expression. All right, let's go ahead and try this numerically. So step 1 is to remove those parentheses. So we've got 2x minus 4 plus 3x minus 7. Okay. Go ahead and color code our like terms. So I'm going to color code 2x and 3x. And minus 4 and minus 7. Okay. Combine like terms. 2x plus 3x is positive 5x. Minus 4 minus 7 is minus 11. So again, our simplified expression is 5x minus 11. And again, you can see we got the same answer no matter what method we did. All right. We got one more to try like this. 4x minus 2 plus x minus 4. Okay, so again, let's go ahead and start by modeling our expressions with our algebra blocks. So I'm going to start with 4x minus 2. So I'm going to model my positive 4x over here. Okay, minus 2. So here's my 4x minus 2. And then I'm going to model on the bottom here x minus 4. So again, I've got x minus 4 showing in the bottom. Go ahead and take a picture and drop that into GoodNotes. Okay, next step is to combine like blocks. So I'm going to go ahead and combine all my x's and combine all my green blocks on my negative side here and go ahead and take a picture. And drop that into GoodNotes. Okay. Last step is to write down that simplified expression we've got here. So we've got a total of positive 5x minus 6. So our simplified expression is 5x minus 6. Okay, let's go ahead and try that numerically. So again, write your expression by removing your parentheses. 4x minus 2 plus x minus 4. Next step is to color code your like terms. So I'm going to color code 4x and x, and minus 2 and minus 4. Okay, combine your like terms. 4x plus x is 5x, minus 2 minus 4 is minus 6. So I can say our simplified expression is 5x minus 6. And again, you can see we got the same answer using both methods. Okay, the next thing we need to talk about is sometimes when you add linear expressions, you also need to use your knowledge of the distributive property. You can see here in this example, we've got a number outside the parentheses. And remember, a number directly outside of the parentheses like that means that we need to multiply. Okay, so we need to actually use the distributive property first before we start combining any like terms. So in this case, we're just going to solve this numerically. Step 1 is to use the distributive property to distribute the 2 to each term within the parentheses, or multiply it times each term. So I'm going to start by multiplying 2 times x to get 2x, okay, plus 2 times 3 is 6. So again, we took that 2, we multiplied it times the x to get 2x, and we multiplied 2 times 3 to get 6. And since we had an addition sign here, we're placing our addition sign here. Okay, go ahead and add on the rest of the expression, plus 3x plus 1. Okay, so now we've got our expression after the distributive property has been used, we're going to go ahead and color code our like terms now. So go ahead and rewrite that expression. And we're going to color code 2x and 3x, those are like terms. And we're also going to color code positive 6 and positive 1 together. All right, 2x plus 3x is 5x, and then 6 plus 1 is 7. Okay, so our simplified expression is 5x plus 7. All right, let's try one more like that. So again, you can see we've got this number outside the parentheses, right next to the parentheses. So we're going to need to distribute it to each term within the parentheses. And note that this time we have a subtraction sign in the parentheses. So we're going to start with 5 times x, which is 5x, minus, since we have a subtraction sign, 5 times 4, which is 20, plus 2x minus 7. So we've used our distributive property. Okay, go ahead and rewrite your expression, and then we're going to color code our like terms. So I'm going to color code 5x and 2x. And I'm going to color code minus 20 and minus 7. So let's go ahead and combine our like terms. Okay, so 5x plus 2x is 7x, minus 20 minus 7 is minus 27. So our simplified expression is 7x minus 27. Okay, now let's apply these adding linear expressions idea to a real world problem. Okay, so the directions here say to write a linear expression in simplest form to represent the perimeter of the triangle. Remember, perimeter is if you were to walk all the way around the triangle, how far would you have walked? Okay, so step 1 is to write a linear expression for the perimeter of the triangle. So we're going to write, okay, we're going to add up all 3 sides. So 3x minus 3 plus 2x plus 9 plus 5x. Okay, next step is we're going to rewrite this without the parentheses and color code our like terms. So 3x minus 3 plus 2x plus 9 plus 5x. Okay, go ahead and color code all your like terms. So 3x, 2x, and 5x are all like terms. And then minus 3 and plus 9 are like terms. Okay. And we're going to go ahead and combine our like terms. 3x plus 2x is 5x, plus 5 more x is 10x, okay? Minus 3 plus 9 is plus 6. So we get 10x plus 6 centimeters is the perimeter of the triangle in simplest form. All right, let's try one more. A rectangle has side lengths x plus 4 feet and 2x minus 2 feet. Write a linear expression in simplest form to represent the perimeter. Okay, first of all, let's go ahead and fill in our diagram or our picture with our information. So since this is the shorter side here, we're going to go ahead and label those sides with x plus 4. So each of these sides are going to be x plus 4 feet. And remember, with a rectangle, opposite sides are equal or congruent to each other. Okay, opposite sides are equal or congruent. Okay, I'm going to label each of these sides 2x minus 2 feet and 2x minus 2 feet. So go ahead and write a linear expression for the perimeter of the triangle. Okay, so let's go ahead and write that down. Remember, perimeters, if you walked all the way around the rectangle, how far would you have walked? So x plus 4 plus 2x minus 2 plus x plus 4 plus 2x minus 2. That's our linear expression to represent the perimeter. Now let's go ahead and remove our parentheses and color code like terms. And just be careful, since this is a long expression, make sure you don't miss any of the terms. Okay? Alright, so let's color code all our x's together. And then let's color code all of our regular numbers together. Don't forget that minus goes with the 2. Alright. And let's go ahead and combine like terms. X plus 2x is 3x, plus x is 4x, plus 2 more x is a total of positive 6x. Okay, now let's add our whole numbers. 4 minus 2 is 2. 2 plus 4 is 6. 6 minus 2 is 4. So we get 6x plus 4 feet is the simplified form of the perimeter of the rectangle. Okay, now we're going to start talking about subtracting linear expressions. Okay? When we discuss subtracting linear expressions, we need to first review our knowledge of additive inverse. Okay? So when we talk about additive inverse, remember, like let's say I gave you the number 7, you would tell me the additive inverse of 7 is negative 7 because 7 plus negative 7 equals 0. Okay? So remember, additive inverse is the opposite of a number. Okay, so if you added it together, it would equal that 0. Right? The main question we're going to be focusing on when we subtract linear expressions is, how can you use the additive inverse to help you subtract linear expressions? So we'll be learning how to subtract linear expressions both with the algeblocks, okay, and numerically. But at the end of this, you want to be able to connect additive inverse to subtracting linear expressions. Okay, so our first expression is 6x plus 3 minus parentheses 2x plus 2. We're going to start by using the algeblocks, and notice that the method for the algeblocks, the steps are a little different than when you add. Step 1 is to actually model only the first expression, so 6x plus 3. Okay? Then what we're actually going to do is take away the second expression from the first, and that will give us our simplified expression down at the bottom here. Okay? All right, so let's start by modeling 6x plus 3 with our algeblocks. So we're going to model 6x plus 3. So I'm going to put 6 blocks out here to represent my positive 6x. Okay, that's my positive 6x. And I'm adding 3. I'm going to put 3 green cubes here. Okay, and this is our first expression, 6x plus 3. So go ahead and take a picture and drop that into GoodNotes. Okay, now the second step that's different from adding. Now we're subtracting, so we're going to be taking away the second expression. Our second expression is 2x plus 2. So we're going to take that amount away from our original expression, 6x plus 3. Okay, so let's go back to our algeblocks. And again, we're going to take away 2x and 2. Okay, so I'm going to be taking 2x away. Okay, it's gone. Say goodbye. And also taking away 2. Okay, so here's what we're left with. To go ahead and take a picture. And drop that into GoodNotes. Okay, so here we need to write down our simplified expressions that's being shown here. So here we've got positive 4x plus 1. So that's our simplified expression for when we're subtracting. Okay, 4x plus 1. Okay, so now let's try the same problem numerically. Okay, and again, the steps are a little bit different than when we added linear expressions. Step 1 is to find the additive inverse of the second expression. So we're just going to now take a look at 2x plus 2, okay, and we're going to write the additive inverse of that, which would be the opposite of 2x is negative 2x, and the opposite of 2 would be, adding 2 would be minus 2. So 2x plus 2 becomes negative 2x minus 2. Now we're going to rewrite this, removing our parentheses, we're going to rewrite the whole expression, okay? Our subtraction sign in the middle here is going to change to addition because now we've applied the subtraction sign to both of the values inside and made this negative 2x minus 2. Okay? So watch carefully here. So we're going to write 6x plus 3 is normal plus, okay, negative 2x minus 2. And I'm just putting parentheses around the 2x, negative 2x, so you can see that negative sign goes with the 2. Okay? Alright, so now let's go ahead and color code like terms. So 6x and negative 2x. And 3 and minus 2. Okay, and then let's go ahead and combine our like terms. So 6x plus negative 2x leaves us with 4x, and then 3 minus 2 leaves us with 1. So our simplified expression is 4x plus 1. Again, you can see we get the same answer both times, so we know we did it correctly. Okay, okay, let's try another one. Alright, now we've got 2x minus 3 minus x minus 2. Again, let's try this first with algebra. So we're going to model our first expression, 2x minus 3. Okay, so I'm going to model my positive 2x minus 3. Okay, got my 3 on the negative side here. And go ahead and take a picture. Okay, now we're going to take away the second expression from the first. So we're going to be taking away x minus 2. Okay, so the first part of that is relatively easy. We're going to take away 1x. Okay, so that's gone. Now, the expression is x minus 2. Remember we learned that taking away a negative in our hot air balloon unit actually makes the balloon go up. Okay, so what we're really doing here is we're going to be taking away 2 of the negatives. Okay, we're taking away 2 of the negatives since it's minus 2. Okay, so we're actually making it more positive by taking that away. So here's our simplified expression, x minus 1. Okay, go ahead and take a picture and drop that into GoodNotes. Okay, last step, write our simplified expression, which is x minus 1. Okay? Okay, so now let's try this numerically. So remember, step 1 is to find the additive inverse of the second expression. So our second expression is x minus 2. So again, we're going to find the opposite of each part. So instead of x, we're going to write negative x, and instead of minus 2, we're going to write plus 2. So the additive inverse of x minus 2 is negative x plus 2. Okay, now we're going to rewrite our expression, removing the parentheses and writing our additive inverse in. So we're going to write 2x minus 3 plus negative x plus 2. And again, those parentheses are just to show the negative sign goes with the x. Okay, so let's go ahead and color code. So 2x and negative x are going to go together. And minus 3 and positive 2 are going to go together. And let's go ahead and combine our like terms. 2x plus negative x is x, and minus 3 plus 2 is minus 1. So our simplified expression is x minus 1. And again, you can see we get the same answer both times. Oops, let me move that up for you. There you go. So you get the same answer both times here. All right, let's go ahead and try another one. Okay, so now we've got the expressions 5x minus 9 minus 2x minus 7. Okay, so again, let's try this first with the algebra blocks. So we're going to model 5x minus 9. Okay, so I'm going to model my positive 5x over here. And then we're going to have 9 over here. Okay. So I've got 5x minus 9 showing. Go ahead and take a picture. Drop that into GoodNotes. Okay, and we're going to go ahead and take away our second expression, which is 2x minus 7. So again, we're going to be taking away positive 2x, okay? And now we're taking away negative 7. Okay, we're taking away negative 7. So we're going to take 7 of these away. Okay. Go. And go ahead and take a picture. Drop that into GoodNotes. Okay, and then last step is to write our simplified expression, which is 3x minus 2. Okay? All right, let's try this numerically now. So again, we're just going to start by finding the additive inverse of the second expression. So 2x minus 7 is going to become negative 2x plus 7. Okay, finding those opposites. All right, let's rewrite our expression now using our additive inverse and taking out the parentheses. So 5x minus 9, okay, plus negative 2x plus 7. And again, let's go ahead and color code our like terms. So 5x and negative 2x will go together. And minus 9 and plus 7 will also go together. And let's go ahead and combine like terms. 5x plus negative 2x is 3x. Minus 9 plus 7 is minus 2. So again, our simplified expression is 3x minus 2, which is also what we got earlier, so we know we did it right. Okay, we've got 2 more left like this to go. All right, negative 2x minus 4 minus 2x. So again, let's start by modeling negative 2x minus 4. Okay, so this time our x is negative, so I'm going to put my negative 2x on my negative side here. Okay, and then we're also taking 4 away, so those are going to go on my negative side. Negative 2x minus 4 is showing. Go ahead and take a picture. And drop that into GoodNotes. Okay, and now we're going to go ahead and take away that second expression. So we're going to take away 2x, okay? So we're going to go ahead and take that 2x away, okay? Oh, you know what? Hold on a sec here. Since we're actually taking away okay, sorry about that. So we've got negative 2x minus 4 showing. And we want to take away positive 2x. But the problem is we don't have positive 2x to take away. So what we have to do is actually add on 2 more negatives over here. Okay, since we don't have 2x to take away from here, we're adding on 2 more negative x's over here. Okay, so this is our simplified expression. Go ahead and take a picture and drop that into GoodNotes. Okay. And we're going to go ahead and write our simplified expression, which is negative 4x minus 4. Okay, so let's try this numerically now. So again, find the additive inverse of the second expression. So 2x becomes negative 2x. So let's go ahead and rewrite this as negative 2x minus 4 plus negative 2x. And go ahead and color code like terms. Our minus 4 is all by itself. Go ahead and combine like terms. Negative 2x and negative 2x is negative 4x minus 4. So again, our simplified expression is negative 4x minus 4. And we can see we got the same answer both times. Okay, just one more to try this way. 4x minus 4 minus negative 2x plus 2. So again, let's start by modeling that first expression. So we're going to model 4x minus 4. So we're going to show my positive 4x, okay, over here on my positive side. And then minus 4 over on the negative side. So we've got 4x minus 4 showing. Go ahead and take a picture. Drop that into GoodNotes. Okay, and now we're going to take away the second expression, which again, our second expression is negative 2x plus 2. Okay, so again, we want to take away negative 2x, but we don't have any negative 2x. So instead of taking away negative 2x, we're going to add on 2x to our positive side. Okay? And then we also need to take away positive 2, but again, we don't have positive 2, so we're going to have to add on the negative 2 to our negative side. Okay? Go ahead and take a picture. Drop that into GoodNotes. Okay. And then we're going to go ahead and write our simplified expression, which is 6x minus 6. Okay? Let's go ahead and try this numerically. So start by finding the additive inverse of the second expression. So negative 2x plus 2 becomes 2x minus 2. Finding the opposites. Opposite of negative 2x is positive 2x. Opposite of plus 2 is minus 2. So let's go ahead and rewrite our expression. 4x minus 4 plus 2x minus 2. And then go ahead and color code your like terms. So we've got 4x and 2x. And minus 4 and minus 2. Okay, combine your like terms. 4x plus 2x is 6x. Minus 4 minus 2 is minus 6. So our simplified expression is 6x minus 6. Okay, and again, you can see we got the same answer both times. All right, we've got one more problem before we're done with our notes. This is a real-world problem to help us connect the ideas. It says a hat store tracks the sales of college and professional team hats for M months. The number of college hats sold is represented by 6M plus 3. The number of professional hats sold is represented by 5m minus 2. Write an expression to show how many more college hats were sold than professional hats. Then evaluate the expression if m equals 10. Okay, so let's start by writing our expression that we're going to, finding the difference, so we want to subtract. So we're going to do 6m plus 3 minus 5m minus 2. Remember, step 1 is to find the additive inverse of our second expression. So 5m minus 2 becomes negative 5m plus 2. Okay? So then rewrite your expression without your parentheses using that additive inverse. So 6m plus 3 plus negative 5m plus 2. Go ahead and color code like terms. So we've got 6m and negative 5m. And positive 3 and positive 2. Combine your like terms. 6m and negative 5m is m. 3 plus 2 is 5. So our simplified expression is m plus 5. Now the problem also asks you to evaluate if m equals 10. So if we plug in 10 for m, we can see that they sold 15 more hats. Okay. Alright, so this concludes our notes on adding and subtracting linear expressions. Be sure to do the note check before moving on.